In this video we're going to go through paper 2 of the 2016 specimen exam. So this wasn't a real exam, but produced by the exam board to show what would be included and the style of questions. So we're going to work our way through some of these questions, look at how to go about them, and a bit of exam technique as well, just to help you as you prepare for the real exam. So just to point out, it's an hour and 45 minutes. That applies to both the exams, paper 1 and paper 2. Paper 1's the theory one, paper 2 is the problem solving and programming. And it's also worth bearing in mind that this second paper is worth less marks. So the maximum number of marks is 50 on this paper, and for paper 1 it's 75 marks. And then, hopefully you're aware already, but this paper is broken down into two sections. Section A is questions that are just about the pre-release tasks, which hopefully you've done in lessons already. So they recommend you spend 40 minutes roughly of the 1 hour 45 on section A, and then obviously the rest of the time, so that's just over an hour, you spend on section B, which is just general programming questions. And before we start looking at this one, I'm just going to flick to this is part of the mark scheme from the 2017 paper, so the real exam. And it's worth just noting this paragraph here. The mark scheme is published as an aid to teachers and candidates to indicate the requirements of the examination. It shows the basis on which examiners were instructed to award marks. It does not indicate the details of the discussions that took place at an examiner's meeting before marking began, which would have considered the acceptability of alternative answers. So, in short, what that means is just because an answer doesn't appear on the mark scheme doesn't mean it wouldn't gain marks. The mark scheme sets out the recommended answers maybe, or the most obvious ones, but alternatives will be taken into account. Okay, so let's dive in and have a look at the first questions. So section A, as I said, here's a repeat of the pre-release material that you would have worked on in lessons. This one's obviously a different topic than you will have worked on this year. So this one, it was about a teacher with a class of 30 students who had sat some tests, and the program was going to ask the users to enter data and store the data and output various things like total scores and average scores and so on. I'm not going to get too involved in the detail of that. We're mainly just going to look at the style of questions for this, because they seem very consistent with other exams in this series. So question 1. All variables, constants and other identifiers should have meaningful names. Declare the array to store the students' names. So that's just an easy starting point, a 1 mark question. A very similar question was in the 2017 paper. So declaring an array is just about setting up the array ready to be used. Now, I'm teaching this course using Python. The Python way to declare an array is to just use empty square brackets. So we might write something like class array equals, and then some square brackets. That's how we would declare an array in Python. Technically, in Python it's called a list, not an array, but they perform very similar functions. However, in a lot of languages, when you declare an array, you actually tell it how many items are going to be in that array and set it. It's set to that amount. So if I wanted an array that could store 50 items, I could declare it like that. Or equally, I might have to put something like 1:50, meaning they'll be from 1 to 50. So if we just see that on the mark scheme, there is their one sample answer on the mark scheme. Student names, square brackets, 1:30. Now if you were to put an equal sign there, I'm pretty much guaranteed you will not be marked down for that. They have to take into account students are studying different languages on this course. As to whether you would have to put the numbers in, that's a bit harder to predict. I would recommend that you did at least put the total number in, like the 30 in this case. Even though that might not be the way it's done in the language you've learned, such as Python. Okay, the second part of the question, declare the arrays to store each student's marks and total score. So, similar idea, you just got to have a good understanding of the question. You've got to name the array suitably. It says they must be meaningful. So if you gave a name like, I don't know, array 1, you wouldn't get the mark. It's got to have a suitable name. and then we've got one more called student total score there. Okay, so that gets us the 2 marks. Moving on to the next part. Show the design of your algorithm to complete task 1 and task 2 using pseudocode, programming statements, or a flowchart. Do not include any of the validation checks. So again, this is the kind of question that could well crop up on any paper regardless of what was in the pre-release. And it's interesting that they give you these options, either pseudocode, programming statements, or a flowchart. So by programming statements, that's showing that they're flexible. If you were to write your code purely, or your pseudocode I should say, purely in a Python kind of style or a Visual Basic kind of style, you won't get marked down for that. You're purely being marked on the logic, whether what you write down makes sense or not, and whether it would solve the problem or not. With questions like this, really read it carefully. If it says do not include any of the validation checks or input prompts, then save yourself a lot of time by not doing that. Okay, you could put those in, you won't be marked down for it, but you don't gain any marks, so don't waste your time. This is a 8-mark question. So roughly speaking, you should be spending 8 minutes on that question, and you can't afford to be wasting time. So we'll look at the sample of this one in terms of how it's marked. So each of these bullet points or dashes here is enough to earn you 1 mark. So on a question like this, even if you can't remember the whole thing, have a go at the parts of it you can do. So you get 1 mark for writing an appropriate loop that zeroes the total for the loop. So for example here, we've got some storing the value 0, and we've got an outer loop that goes from 1 to 30 using a temporary variable count. So even if you wrote those 2 lines, you can earn marks, is the point. And it says input the name and all the test scores. Again, that 1 line there and inputting the scores gets you marks. So that line and that line there get you another mark. Okay. Again, if you wrote that in a Python style, the Python way of writing that input name would be more like this. Name equals input. So if you wrote that down, you get the marks, it's fine. You don't have to follow the exam board style of pseudocode. Okay, and again, we won't go through the whole thing in detail because this isn't relevant to the task you'll have been working on, but that's the key point. Each section, each thing gets you a mark. So even if your whole program doesn't work, make sure you get down the parts that you can do. So you should all be able to set out a loop, initialize the variables, take the input from the user, and hopefully then you'll be well on the way to a few marks, and then you can start worrying about the actual content. How do we calculate the total, for example, in this one, and how do we store it at the right position in the array, and putting that all together is the way that we're going to come up with a high mark, the 6, 7, 8 marks for a question like that. Okay, let's move on. This one might seem a little bit more vague. Comment on the efficiency of your design for part 2. So let's just have a look at that. In the mark scheme, it's equally vague. Any relevant comment with regards to efficient code, e.g. a single loop. So just think about, if you've done something in your algorithm which isn't very efficient, like it would take a long time to run, or there's possibly a better way of doing it, then you comment on that. So that, again, not too bad for 1 mark there. Okay, the next part show 2 different sets of student data that you could use to check the validation used in task 1. So forget about what you answered in question 1 almost here, because that didn't involve validation. Now you're thinking back to what you've done in lessons where you have validated the data entered by users. So set 1, you think of what data would suitably test the program working. So at this point you're thinking what could be some invalid data that the system should pick up. For example, if you were meant to type in a number, an integer value, and you typed in a string, hopefully your program could deal with that. So your data set could reflect that by including text instead of numbers. And then the reason for choice would be to check that the program validates this being a wrong data type, and so on. So in this one, they asked for 2 examples of this. Again, this would be very common. So pretty certainly in your exam this year there'll be a question talking about data that you can use to test your program and why that is suitable data. So the mark scheme makes very clear straight away there are many correct answers. These are examples only. So it's not that you have to answer with these numbers. So in this case it was about the range of the values. So those were 3 sets of valid data to check the data on the upper bound of each range check is accepted. And this one included invalid data. So 36 must have been higher than a mark that wasn't possible if the test was marked out of 35, for example. So that would be invalid data. Okay. And then moving on, this will be where task A is slightly harder because it's looking at the third part of the task. So task 3 on any pre-release is going to be the harder elements of the task. So again, first thing to do is always check how many marks for the question. So there's 5 marks for this one. Explain how you select the student with the highest score, task 3. You may include pseudocode or programming statements to help illustrate your explanation. So notice that they've dropped the option of flowcharts here. I assume just because it'll be a bit too complex to show using a flowchart. So part D has the mark scheme. We'll not look at this in depth again, because you'd have to really understand the task in detail, and it's not worth wasting time on that. But maximum 5 total marks for the question part, maximum 3 parts for the algorithm. So the question did ask you to explain. Okay, so it wasn't just about giving code, it was about explaining it, and that's reflected in the mark scheme. 5 marks for the question part, maximum of 3 marks for the algorithm. So you could be amazing at coding a solution, but if you don't explain it well, you wouldn't still come out with full marks. And then part 2, how does your program work when there is more than one student having the highest score? Again, explain using your method given in part D1. So you refer back to what you talked about in this question and explain. You've got to be always looking out for these command words to understand what's being asked of you. If you see the word explain, even for a 1 mark answer, you're not going to be doing a sort of 1 word, 2 word answer. That's not explaining. If it says state, that's a different matter, but if it says explain, you've got to earn that mark slightly differently. So here we go, comment on which student's name will be output. Either the first student with the highest score will be output. And I think that's the end of section A. Yes, here we go. So then we move on to section B, which is questions that are not specific to the pre-release, they're just programming in general. So this is where we can start looking in a little bit more depth at what we're working on. So with questions like this, where you're faced with an algorithm, it's maybe not always clear what's happening, especially if the variables haven't been named in a suitable way. The best thing you can do, you might want to dive in and just try and work it out yourself, but the best thing you can do is to write a little trace table. The trace table sounds complicated, but all it means is just write down all the variables as headings and work out what's going on. So I've just made a little table here. So the variables, we've got C as a variable. We input the pin, so that's a variable as well. Then we've got X as a variable. So you just literally work your way through, like kind of scan through the program, look for anything that you think might be a variable. X and C are repeated, X and C, and then we print out some output at some point. So I might just do one for output there. Okay. Then we go down to the actual question part here. A, what value of C and what message will be output if the following pins were entered? Okay, so we just work our way through line by line and see what happens. So the value of C is always going to start at 0. So I'm going to put that in my table. Then we input the pin. So here is the first pin, 51020. So 51020. That's the second line done. Third line, and in the exam you might want to tick them off as you go, keep track of where you're up to. So now X is going to store the pin. So that just means copy the pin into the variable X. So 51020. Up to this line, repeat. So we've got a repeat until loop. Those of you who, like me, are using Python on this course, we don't have a repeat until loop. You can think of it like a while loop in reverse almost. The condition is this part at the bottom, and it will always complete the code at least once, because it says repeat, then you get the calculation or whatever it might be, and then you check whether to continue or not. So a repeat until it will always repeat once. And the first thing it does is x is going to store a new value, x divided by 10. So we look at x and we divide it by 10. Now in this case we can just remove the 0 basically to find the division by 10, and we store that as the new value of x. So 5102 is the new value of x. Okay, and then we go to the next line. C is going to store C plus 1. So the fact that it's a plus 1, you might think, okay, so C, probably what it really means is it's a counter. You know, often in programs we have some kind of counter variable. Okay, so we're gradually starting to make sense of what it's doing. Now we get to our condition, until x is less than 1. You've really got to be confident of your less than and greater than sign. It's a common mistake that pupils make in exams. Just an easy one to get tripped up by. So make sure you're confident of which way around less than and greater than go. So is x less than 1? No, it's not. It's equal to 1. So we do repeat. So we go back around the loop. We carry on from here. X is going to store x divided by 10 again. So if we were to divide the current value of x by 10, we'd go 510.2. Okay, and then we go C stores C plus 1. So C is going up to 2 now. Okay, we check the condition again. Is x less than 1? No, it's not. It's still got much higher than that. We repeat again. X becomes x divided by 10. So x is going to go to 51.02. And C becomes C plus 1. And we go check the condition again. Is x less than 1? No, it isn't. Loop back round again. Divide by 10 again. So we're now at 5.102. And C adds 1 again. Check the condition. Is x less than 1? No, it isn't, because it's 5.1. So we loop back round again. And then divide by 10 one more time. So dividing that by 10 will end up with 0.5102. And C is going to store C plus 1. So that's 5. Check the condition. Is x less than 1? Yes, it is, because it's now 0.5. So we finally got out of this loop and we continue. If C, this symbol means not equal to 5. In other languages like Python, we would use exclamation mark equals. But this is just another way of writing not equal to. So if C is not equal to 5, well, in this case C is 5, so we would skip to the end, and that would be at the end of our program. Oh, in fact, sorry, no, correct myself there. If C is not equal to 5, then we do this branch, else we do this one. So what we do is print pin OK. So that is our output there. Okay, so the value of C at the end of that loop is 5, and I think I've just missed out a bit. It should say message as well, which would say pin OK. The second time round, I won't run through the whole program, but you can see what's going to happen. It's not going to repeat as many times. It's only going to have to go through the loop 4 times to get to the point where x is less than 1. So when we hit this final test here, this condition, is C equal to 5 or not? Or if C is not equal to 5, well, it won't be equal to 5, it will be 4. So on that second one, it will print error in pin entered. And then we can see really this system is expecting a pin number to have 5 digits in it rather than 4 digits. So that pretty much summarises this question. So just coming back to the mark scheme, that's what they're expecting. So for 1 mark, we should have had a value of C as 5 and the message pin OK. For the second mark, the value of C would have come out of 4 with this input with less digits, and the message should say error in pin. Because it's possibly quite a lot of thought involved just to get those 2 marks, but obviously I've gone slower than you would because I've been explaining it. And then the second part of the question just asked what type of validation check is being carried out here. So as we've seen, it's just checking, are there enough digits? It's not validating is the pin correct or not, it's just checking how many digits were in the pin. Back on the mark scheme, you can see that's just simply a length check. So you need to be aware of those different types of validation, like range check, length check, and so on. Okay, so we'll leave it there for this video and continue in the next one.